Hi guys, welcome back to the channel, and before we get started we have our typical housekeeping announcements that this video is sponsored by AMD and all thoughts and opinions expressed in it are mine and mine alone and do not represent those of any company I am currently or have previously been associated with. So, with that out of the way, let's get into it. So in my last video, the algorithm powers that be decided that they really liked it, and I got a lot of new viewers, which came with a lot of questions about my basic setup. And since I haven't done this in a while, I thought I would go through and show my full Linux Ubuntu installation through to a fresh Vivado installation and followed up by a choice of basic FPGA development board setup. More geared towards a beginner / travel desktop friendly format. But with all that said, since this video is kind of in 3 parts, I will say if you want to skip straight to the actual installation of the AMD tools themselves, go to this timestamp, or if you're just interested in how to pick a beginner / desktop friendly FPGA development board, skip to this timestamp. Other than that, let's get into my actual Ubuntu host environment setup. So a little bit of an explanation on my actual host environment setup, because I mentioned I was running Windows in my last tutorial on a Mac. Obviously, I still have a Mac in this video, but I've said that I'm installing Linux, specifically Ubuntu. And if it's not already obvious that you can guess, I am a big fan of virtual machines. And this started when I got more into the Linux world of things. I found that I was kind of scared to blow up my host environment where all of my data files were. And I was already in the Apple ecosystem. I liked how it synced all my files across all my devices. I know lots of you hate Apple, this is just my preference, not trying to. Anyway, and I wanted to not be afraid to blow things up when I was first learning how to use Linux just as my daily driver and install things, because that's definitely a big thing to process. And I found that using a full virtual machine, learning how to install things, when I wasn't afraid to explode things and make magic smoke from a digital perspective, not physical, that's when things got a lot easier. So I have tried several virtual machine software host platforms. I'm not sure the terminology, the underlying software for that. Ultimately, what I use is Parallels for Mac. That is a paid version. There's plenty of free VM softwares out there. So by all means, like VirtualBox, VMware, those are great. I have found, since I use this on a daily basis and I use it for deliverable projects for clients, I need it to be super stable, super reliable, and basically paying for Parallels means I get constant, already tested, stable updates. I pay for the Pro version, which is $120 for a whole year, just like $10 a month, so I think that's a pretty reasonable purchase for me. But like I said, if you're just getting started, there's plenty of free open source versions out there that work well as well. But on top of that, the other thing I like about virtual machines is that you can put them on external hard drives. So I have, over the years, my many years of doing this now, I have accumulated several different versions of Ubuntu on external drives as well as Windows, which has come in handy, I've found. So I think these SanDisk external drives are my favorite. I think there's a version of these that are fairly controversial, but they have, I forgot, there's like a Pro and an Extreme. Oh yeah, these are the Extreme version. I think the Pro version had some corruption errors, but I don't know. I've never had any issues with these, and as you can see, I have my Windows 10 version, my Ubuntu 22.02. This is my x86 emulation that I've been trying on an ARM-based host machine. It's sort of working, I'm getting there. Anyway, that's not the topic of this video. But the cool thing is, I've got my Ubuntu 20, Ubuntu 16. I don't know where my Ubuntu 18 hard drive went, but I have found, not just since I don't only do FPGA stuff, it's really handy if I have some random piece of software I want to try or something, especially in the Linux world. You find things that are only supported on very specific versions of Linux distros. So this has saved me several times on several projects where it's like, oh, I randomly need Ubuntu 16 to try this piece of software that hasn't been updated in a long time. My last video about Daisy Lab was actually my Windows 10 VM came in handy compared to my Windows 11 since the last official update was for Windows 10. So there's lots of different scenarios where having different host OSs has come in handy and saved me on projects. Anyway, that's the backstory on why I like using a virtual machine setup. Parallels as a host lets you have, I think, an indefinite, well, probably not an indefinite number, but I have all of these I'm able to use in the same Parallels installation on this computer. So, with that said, there are some steps to actually getting that installation done, pulling down a version of Ubuntu, and getting it installed on an external hard drive. So I have a fresh hard drive here, even though I already have an Ubuntu 22.004 installation over here. I think I'm gonna start a fresh one because I've actually almost filled that hard drive. These are all 2 terabytes a piece. As kind of there's a couple 1 terabyte, but 2 terabytes is a good size I found for longevity purposes of projects. I think because the AMD tools are a little bit of a space hog, because I like to do full installations rather than depending on an internet connection, so I need lots of space. I think I have, my other Ubuntu 22.04 drive has 5 versions of the AMD, like Vivado, Vitis, and Parallels, or PetaLinux on it. So it's a little full. We're gonna start a new one today, and we're going to install Vitis, Vivado, and PetaLinux version 24.2 on it, which as of right now is the latest version. So let's get into that. And before the Docker container lovers come for me, I know I'm still learning Docker container, that I haven't gotten it to work quite the same way I like as with my VM setup, but I know, don't hate me. But feel free to leave your opinions of Dockers versus VMs in the comments. Anyway, okay, let's plug in our fresh hard drive here and get Parallels open. I will say, as a note for Parallels or any other VM machine, make sure if you're using a hard drive, before you launch it, make sure you have the hard drive plugged in and that the base host PC has actually detected it. That is the only kind of risky thing about running on external drives, is accidental ejection can cause lots of problems. All right, so I've got my control center open here, and as you can see, I've got several previous versions here, and I don't have all of my external hard drives plugged in, so that's why I've got all these lovely warnings. What we're gonna do is we're gonna do a new virtual machine, and I have, as a side note, before you do this, you do want to download the ISO installer for the whatever version of Linux you want, whether that be Red Hat, Ubuntu, whatever specific version. I'm starting off with a slightly older version of Ubuntu 22.04 just to satisfy Vivado, Vitis, PetaLinux initial installation requirements and support. I'll explain that a little bit more in the actual installation of those things, but where you can find those on is if you go to the actual web page for whatever distro you have. So in this case, it would be Jammy Jellyfish. And it's got whatever's on this page is the latest version, but then you can go to the indexed release history. So this is where you have 22.04, 0.01, 0.02, so on and so forth. I've already downloaded it just to save a little bit of time because it is a few gigs in size. For this purpose, if you're doing a full desktop environment like what I'm doing here, You want the name dash desktop dash, we're doing AMD 64, so this is an x86 based PC, so if you're doing ARM, you want dash ARM or whatever your particular core chip is, or your CPU is, or architecture, couldn't think of the word, whatever your architecture is. So because we're coming in with our own ISO image file, we're going to choose the option to install from an image file. The rest of these would actually download the image file in the background for you, which again is just the default latest version of whatever. So if we did the download Ubuntu Linux from here, it would download, I believe the latest version is 24.04 right now. I don't know, I'm always a little bit behind because it takes me a minute to get up to date. So we'll do continue, and then Parallels auto detects all the ISOs you have in your folder structure or your file structure. So as you can see, I've got a few. This is my downloads version. So we're gonna select, and then we'll give it, this is the name that's gonna be here in your control center. So Ubuntu, I'm running out of, got a few names here already. It's 22.04. This is our second version of this. Yes, yes. So, and my default location, this is within my actual computer, but I don't want it there. I want it on my external hard drive. When you're doing an initial installation like this, I recommend only having one of these installed, because at least with these hard drives, they all pop up as the exact same name and they're not easily differentiable. So one thing at a time. So I'll do that. And I do want to customize settings before installation, because it will default to a specific hard drive size, specific amounts of RAM. The big thing is we want to change the hard disk space, because I think the default's only like 60 gigs, which is not enough room to do anything, at least for FPGA developers. So create, and that's gonna open up our options to configure. So hardware for processors, with any virtual machine platform, whether it be Parallels, VMware, any of that, whatever actual amount of like RAM, hard drive space, CPU cores, don't allocate any particular VM, or don't give any particular VM full access to all of it, in case you do something dumb inside the VM. So I learned this the hard way when I used to give all of my VMs full access. I have 64 gigs of RAM. I let it access all 64 gigs of RAM at once when it was running, all the CPU cores, and if you do something dumb and cause some process to hang, cause a memory leak, any of that, if it has full access, it will consume up all of your RAM, all of your memory, and then not let the underlying host function and just choke everything. I recommend about half, seems to be a good happy medium. No more than 3/4. Like, always leave something for the underlying host machine to actually be able to survive should you do something dumb inside your VM, which that's what my VMs are for, doing dumb things in. So I'm going to give this 8 processor cores with 32 gigs of memory. There we go. That's not exactly 32 gigs, but close enough. And which, by the way, 32 gigs of memory is what's recommended in the Vitis Vivado installation requirements. And for hard disk, so yeah, disk capacity by default for VMs is only 64 gigs with Parallels. I found that's the same in VMware and VirtualBox, at least the older previous versions that I've used. I haven't used the most recent ones. So properties, I'm just gonna give it all, since it's on my external hard drive here, this is 2 terabytes, it's the only thing it's for, so it gets the full 2 terabytes because that's here, not here. And I will say, if you do forget to do this, on a fresh VM, you can use something in Linux like gparted to resize the drive itself. It's just that's a little bit risky. I've done it, but it is also easy to corrupt things and have to start over. Which again, anytime you change the hard drive space, that's why it gives you this warning, because it's gonna overwrite whatever's there. Click OK, and those are the main. Is there anything else? I'm not a big, we'll let it do auto graphics space. I don't do a ton of super graphics intensive things outside of PCB layout, so the rest of this is just letting, Parallels is really good about sharing resources or like external hardware with your VMs. That's another big reason that I feel like Parallels kind of stands out and is worth paying for, is I have never had hardware connection issues with it, aside from one release that had an initial bug in it, but that they updated it pretty quick. So yeah, I'm gonna leave all this on just shared with the Mac environment. Share, have any Bluetooth or smart card, and I can always update these later, so USB, ask me what to do. So with USB, I just leave it on the ask me what to do, so anytime I plug in a USB device, Parallels will ask me, do I want to connect it to the virtual machine or the Mac itself? So I'll just leave, I prefer that because sometimes I go back and forth. I think I can leave the rest of these at their defaults. The only thing I do want to make sure, so I do mirror Mac and Linux user folders. That lets me access my documents folder on my Mac side from within my VM. In Linux, now that I'm a little bit more confident that I'm not going to completely blow everything up, I do like this option, particularly because I have anything in my documents folder on the Mac side set up to automatically back up to iCloud. So it's nice to store project files there, so it's automatically backed up kind of redundantly through iCloud. And I think that's all I need to change for now. At least that's all the stuff I need to change before actually running the installation. So now that this is all, oh, this is another good one I don't use, but if you want to sandbox it, then completely isolate your VM from the host machine, which is good if you're potentially wanting to have a VM where you're using it for security or cybersecurity things and you don't want anything getting out. There is this option in Parallels to isolate. I don't want that for this particular one because that's not my use case. And okay, we're good. Stop rambling, just install. Get to our initial Ubuntu setup here. It's thinking about it. There we go. I feel like I always have my volume turned off. I didn't realize that made a noise. So we are going to install English US, yes. We want normal installation. Let's go. Erase disk and install Ubuntu, yes. There's nothing on this because it's brand new. Yes, just really making sure that I want to erase. Yes, I'm in Los Angeles. Okay. So my computer name. Go through. Don't look at my password. And the waiting game begins. Okay, now that the installation is complete, we'll restart. And this part's a little bit tricky with virtual machines, is technically it still has the ISO mounted, so sometimes it'll get stuck. So there we go. Oh, it looks like it's already disconnected. So before I speak too soon, let's get to the desktop. Right, we'll log in. Did I just typo that or forget what I made the past? Nope, just typoed it. So let's also make this a little bit bigger. I don't ever do that. I'll skip. I'm not gonna do Ubuntu Pro. I don't really need that. Sure. You can have my error reporting. I don't need location services in a VM. Okay, thank you. All right. And just because I like to, where's user? You know, setting a profile picture is important, or user picture. So now that we have Ubuntu itself installed and running in our VM, let's get into the actual AMD installation. So as a little bit of backstory with how I prep for a new AMD Tools installation, and I say AMD Tools instead of saying Vivado, Vitis, and PetaLinux all at once. Anyway, abbreviated version. Anytime that there's a new release, I look through the user guides for Vitis, Vivado, and PetaLinux specifically, because that will give you information such as what versions of each OS it's compatible with, what package dependencies you need to install, so on and so forth. I have a system pretty much down pat and an installation script that hasn't changed a whole lot over the years. I do have to add a different package dependency here or there. So I'll just show you kind of how which resources I created that from, and then we'll get into it and as I copy and paste the commands over to step through. So one of the main things I use is UG973. That'll tell me specifically which versions of Ubuntu are supported. As a side note, there are very specific subversions listed here, and you might get some warnings about, oh, your OS isn't supported from particularly PetaLinux, but so far, knock on wood, I haven't really found anything that these minor versions of Linux don't get along with in Vivado. So basically, really, as long as the major version here is supported, you should be okay. I make no guarantees because only what's officially listed here is officially supported. But anyway, also as a side note, I think somewhere AMD says they don't officially support Vivado, Vitis, and PetaLinux running in virtual machines. I personally haven't faced any issues as long as my underlying VM is stable. So the only time I've had issues with it that weren't due to some bug in like Vivado or Vitis itself was something on my end where I didn't set up the VM right, which I think is why AMD says they don't officially support VMs, is because there's a whole layer of things that you can mess up there to make it not run right, but just wanted to mention that caveat. So there's also the Vitis release notes and installation guide, which is UG1742. That also lists the supported versions. Oh, that's interesting. Linux and VM. There is something that says they support VM. That's new. Anyway, but I mentioned this because this is where you can find the recommended system memory levels, which, like I mentioned earlier, when it says for embedded, that's for normal FPGAs, pretty much all of their FPGA cards aside from these Alivo cards. 32 gigs is sufficient or recommended, and then hard disk space is recommended 150. When you're actually installing it, it'll tell you again exactly how much space it's going to use up. So we'll look at that when we get there. And the other thing, so UG973 and then is for Vivado and Vitis, and then PetaLinux Tools. Sometimes I've noticed a little bit of a discrepancy. here between supported versions, it seems to be PetaLinux is a little bit behind. There's typically more supported Ubuntu versions or just OS versions for Vivado and Vitis, and PetaLinux has a little bit narrower pool. So typically when I install, I base all my installation requirements off what PetaLinux says it needs, since that's kind of the narrower scope. That way I don't have to look everywhere, but and you can kind of see that's a lot more narrow here. It needs its own 100 gigs worth of hard drive space, so if you're keeping track, this is a big installation, I know. But you do need about 256 gigs for the installation of the AMD tools alone. So just keeping that in mind, if you're dedicating space to it, whether it's on your core hard drive or external or wherever, because I know that that's a little bit shocking to newer users. And then as far as package dependencies go, to know exactly what to install, I've found if you Google PetaLinux, whatever target version you want, and then product update, release notes, and known issues, there's this really handy spreadsheet that you can download here at the bottom, which I already have, and that will show you, it'll list based upon like which version you're using. I highlighted I highlighted the wrong one. That's Ubuntu Desktop 20.04, but oh yeah, it looks like it's, aside from the version, it's the same packages itself. So you can just come over to the actual tool and library. I just copied this list here, and that's where I initially started my script from. There are some more I've included here for Vitis and Vivado specifically, which I got those. There's a post-installation script that checks for installation dependencies, but I'll show that to you when we get there. So now that we've gone over where to look for your requirements, package dependency lists, let's go to the actual download, which I should probably do in the Ubuntu environment itself. We'll download the actual installer for the installer for Vitis and Vivado is one and the same. So we'll start with that first. So just Google Vitis or Vivado download. And I know, all of the things. So you've got several different options up here. So there's, even though Vivado and Vitis have separate tabs, the installer it points to is the same. So under Vitis, even though it says software versus hardware developer, I typically download it from the software developer just because Vitis, whatever superset Vitis is, it will include Vivado. And there's 3 different versions of the installer here. There is the SFD, which is the single file download. Yes, that's why it's 125 gigs. The single file download it's the actual full installer. It has all the underlying files to install everything from. Whereas these other 2, there's a lightweight web installer, one for Linux and one for Windows. I personally recommend using the single file download. If you don't have 125 gigs of spare space anyway, you're gonna run out. And the only, all of the underlying core files still have to be downloaded. That's the first thing the web installer is gonna do, is going to download all of what's necessary in the background anyway. But I've also found that the web installers are really they don't like to get along with company firewalls. So especially if you're in a professional environment or anything like that where you don't have control of the firewall, the SFD is gonna be a lot easier, or single file download is gonna be a lot easier for you. Pretty much every job I've had, the web installer, I couldn't get through the regular company firewall, which is a good thing, means the firewall's good. Anyway, so I'm gonna do the single file download here. I also just like to have it in case I need to uninstall and reinstall it. Usually I have the installer saved on like another external hard drive, just in case I need to do multiple installations. You can always create an account for free. Oh yeah, if I haven't mentioned that already, Vitis, Vivado, PetaLinux, it's all free to download, free to use. There's just a few select IP cores, like the JSD IP core, you do have to pay. That requires a license, and there's some of the more advanced parts, like the bigger parts, like the ultra scale parts need a license, but other than that, especially if you're a hobbyist just getting started, you can use the vast majority of it for free. Well, my brain cell finally came back into orbit and remembered that things download a lot faster when you hardwire into your router instead of over Wi-Fi. So, while we've got the last 9 minutes of that download of the single file downloader, let's prep the actual Ubuntu environment. So the default shell in Ubuntu is Dash, however all of the AMD tools need it to be Bash. So that's the first thing to do, is change that. So we're going to run this command. Oh, I don't have my clipboard, so sudo, I don't remember the syntax. Reconfigure dash. Oh, if I can type. So you want to use, no, I want to use bash. So there we go. And then you also need the 32-bit architecture to be enabled, because there's lots of underlying libraries for PetaLinux as well as Vivado that use 32-bit libraries as well as 64-bit. So we'll do sudo, I don't know why I can't remember any of these. D package add architecture, and the 32-bit architecture is i386. So now that we've got our shell changed from Dash to Bash, we've added the 32-bit architecture, the next step is to install all of our package dependencies. Okay, I realized I forgot something in the actual installation, well, the VM's installation itself. So part of the Parallels software to help go seamlessly in between your host PC and the VM also requires some software installation on the VM itself, which that's what install Parallel Tools is. So now that my download is complete, so let me close this stuff real quick. Let's install Parallel Tools. Okay. Will it open automatically? I know it mounted itself. Is it gonna open automatically, or do I need to? Let's do install P. Then enter your root password. Thinking about it. So I did have it configured right to share my folders between Mac, and also share, the big thing is sharing my clipboard between Mac and Linux, so I can copy paste and go back and forth. So I had the settings right in the configurator, I just, because this wasn't installed on the Ubuntu side, that's why it wasn't detecting what was in my clipboard from the Mac side. So, yeah, because this will make this go a lot faster, that I can just copy paste my stuff from here. And I kind of want to talk through it, which is why this script isn't fully automated. But yeah, you could, I'll post this script in the write-up version of my installation tutorial, so feel free to automate it from there. Let's restart. So I will say, I don't know if it's just me, I haven't always gotten along with the new window manager, Wayland. So my other Ubuntu 22.04 machine, I always start in Xorg, and I've noticed a couple little weird glitches, so I think I'm just gonna switch to that, go ahead and switch to that for now. I'll dig into that later, but I do recommend if you have any sort of graphical issues with Ubuntu 22.04 in particular, because that's when they switched from the Xorg to Wayland managers from 20 to 22. If you have those issues with a VM, just switch back and boot up into Xorg. Hopefully Ubuntu 24 still has that option, but that's a future me problem, not a today me problem. I have plenty of today me problems already. So, continuing on with the first thing I always like to install on a fresh Ubuntu image is gparted. I use this a lot for, oh, what happened there? Oh, that's because I use Command instead of Control V. So gparted is a graphical interface for partitioning drives. I use it a lot for partitioning the SD cards that run on my microcontrollers or FPGAs, like particularly after I create an embedded Linux image with PetaLinux. You have to partition the SD card appropriately. Yes, you can do it all from the command line. I like using the GUI, the graphical version of it with gparted. And like I said, these are the package dependencies that I got from the spreadsheet from the, that was a copy paste error. So yeah, a lot of these package dependencies, you see I got those from the spreadsheet from the PetaLinux release notes. And then after you run the Vitis installer, it has an underlying script in the installation directory that will check for any missing package dependencies and install them anyway. So every time I do a new installation, I'll run that, and then I also take that and copy paste it back into my own little installation script here. So that's where a lot of these have come from. This order that I have them in here is also from some trial and error as well. Because I found if you try to install too much at once, things kind of barf, for lack of a better term, and then also installing things in the correct sequence helps things from exploding, at least in my own experience. But I'm sure there are much more Linux savvy users watching this, absolutely screaming at me, but educate me in the comments. I would love that. Whoop. Hit enter twice. That's okay. It's installing everything. Keep going through. Oh, it's because it's dev, not devil. Duh. I think that was a holdover from why can't we find zlib? That came from here. Oh, that's because that was my copy paste. Well, that's because I don't need it. It's not a package in these versions of Ubuntu. Good job. To me.
Skip all that.
Hold on. What did I do wrong here? Complex. 9. Why did I broke things? How did I break things? Lib standard already version. This means you may Even though I've done this several times, it's always interesting how I can mess up a fresh installation still. This, I just specified. Is that because I said I must have tried to install uprightly. Let's take off lib standard C++ because I think I'm installing the wrong version of that. Yes. No, was that another copy paste error from here? Why did it? I don't know. I'm not sure why I complained. Let's go through. I'm sure I'll figure it out later. Let's install all Python stuff next. We didn't like Pylint either. Is that another? Oh, that was another. Good job, not paying any attention there. It says NA there, because I just copied this whole list. Well, see what happens when I go too fast. I'm sure I'm not the only one that's made that mistake. So let's keep going here. This is what I get for trying to optimize my script for filming. I should have just left it the way it was. Because I have the order that I know works, and then I tried to, like I said, out of trial and error, had a method that worked. Which one did I just do? Tools. Then good news is I'll clean up this script so that I'll have the right one in the write-up. I always kind of keep an eye on making sure, like when I'm installing a bunch of packages like this, I kind of keep an eye on like if, like, so 12 upgraded, 78 installed, 0 to be removed. Typically, if you're installing a bunch of stuff and every time you run this, you see packages being removed, that means you have conflict somewhere, and then eventually something's gonna blow up. So that's another lesson I've learned the hard way. By no means am I a Linux expert, just trying to get there. Well, not even Linux, just more proficient than I am today. I think that's a better, more achievable goal. And that does bring up another point of, like, some of you at this point are probably asking, well, why not do this on Windows? Why are you on Linux? And that's mainly because I do like to create a lot of embedded Linux images for my designs and not just have bare metal C applications, which PetaLinux only runs on a Linux environment. And you can install a Linux VM on Windows, which that would just be VM Inception for me, so that's why everything's in Linux on this side. And I will say, because this is the last Intel-based CPU MacBook there was, so once this dies, and because the emulation just doesn't work that well, I will be forced into the non-Apple world at that point, which I will be running just Ubuntu as my full environment, because I don't know, I just prefer Apple or Mac and Linux more than I prefer Windows. I don't know, get along a little better. which one? That was OpenCL. And this should be the last of our package requirements here. See? Oh, and I already had, those must have been dependencies previously that got, it's already, okay. We are good to go. So I'm not sure, lesson learned, if you install, where'd it go? The standard C++ library, always specify a version. Don't, there must be something with like the backend, mirror isn't the right term, but the backend server, like when you go to install a package and Ubuntu is looking in the, well for this, so when you're looking in the Jammy Jellyfish repository for installation packages, something about not specifying which standard C++ library you're trying to install must have had it go back to an older version because it was trying to install version 9 when obviously it's version 11 for this distribution of Ubuntu 22. I don't know, I'm fully speculating. I'm sure I'll get schooled in the comments. I always will. Anyway, okay, so now that we have everything prepped, our environment prepped, we'll go ahead and extract our installer here. So we'll give that a minute. And I will say, I am taking up quite a bit of space on the drive here. That's why part of the reason I recommend doing like a terabyte or 2 terabytes for your external drive for your VMs, or just allocating that much drive space for a development environment like this. I will, after I finish this installation, I'll delete the extracted version of this folder, but I'll move this compressed version onto, like, I have just a plain old storage external drive that I'll move this to, so if I have another VM I want to install 24.2 on, I have it, so I don't have to wait on the downloads again. Okay, so now that's extracted. Let's come back to our command line and change directories into that extracted folder. And then we're going to run the installer, which is x setup with super user privileges. And so yeah, this is what I was talking. I think I downloaded. I had 22.04.5, and I think 22.04.4. Okay, so this is what I was talking about. If your minor version is not matching, you'll get these red warnings. Like I mentioned before, I personally haven't had an issue with it, so I'm gonna keep going here. So Vitis, you'll notice Vitis and Vivado are 2 separate line items here. Don't worry, you don't need to rerun the installer and come back and pick Vivado. Because like it explains it here, but Vitis is like the superset. It kind of installs everything underneath except for down here at the bottom, the PetaLinux SDK. That is separate. Basically, this is just downloading the installer for you. We'll get to there, but for right now, we're installing Vitis and Vivado. So that's what this selection is for. And we can come here and customize it. Let's see. Don't need the cache. Typically the default settings are fine. I'm not using the Versal ACAP parts, so I don't think I'll install those. I don't have any of those. You can always rerun this installer after you've installed the IDE and reinstall these parts. It's no big deal. So yeah, it's because it says disk space required, 196 gigs. So that's good. And then all of the obligatory I agree to the terms and conditions. Next. And the default installation is tools/Xilinx. I like to leave it there, but you could select a different install directory. Just make sure you don't install it in somewhere like the dev or devices folder, because that would just be incompatible with the Linux operating system itself. Create program entries, Linux design tools. So these are all the locations for all the different, so you have Vitis, Vivado, Vitis HLS, Model Composer, DocNav. So this shows you everything that's being installed. So the disk space required, that's the actual, like what the installation needs. But then once the installation is done, it'll only consume 149 gigs. And then of course it shows you what you have available. It's like, yes, that does not exist yet, but I do want to create it, that installation directory. And once again, we're off like a herd of turtles. So while this is installing, I'll come back. I think I want to download the PetaLinux installer while I'm waiting on that real quick. So you could rerun this installer and select PetaLinux at the beginning like I just showed you. It would download the installer, or if you kind of want to kill two birds with one stone while you're waiting, you can come back and download it straight from the website here. So I think that's what I'm going to do. The PetaLinux installer is a lot smaller. It's only a couple gigs. What was it? Yeah, or 2.94. Like I said, once we remembered connecting straight to the router versus being over Wi-Fi is a lot faster. And then you'll also notice there's the PetaLinux installer, but also on the downloads page are all the different BSPs for Xilinx development boards specifically. So a PetaLinux BSP stands for Board Support Package. That's just it creates like when you create a new project from a BSP, it just presets everything with all the settings for whatever AMD dev board you're using specifically. So, because like some settings, like if it has an SD card slot or different IO, like that's not where those are, isn't going to change. So it's fine to have that BSP have all that, arrange it for you, versus like you having to do that every single time. So that's what all these are, because you see you've got all the Creo ones. The Creo BSPs, I will say be careful with, because there's the Creo BSPs for just the little Creo SOM by itself, and then there's the BSPs for the Creo on the AMD specific carrier boards. So make sure you get whichever one you actually want. I've made that mistake before. And the other nice thing about starting with 24.2, I noticed, the underlying package for doing like software emulation or hardware emulation in Vitis for your application, your accelerated applications, that used to be a separate package install. Now it's just built in to the actual installer we're running now, so the underlying runtime tool. Although I did see a depreciation warning. It looks like software emulation is gonna go away starting with 25.1. Yeah, so depreciation of software. So looks like 24.2 is your last, if that's relevant to you, if you use software emulation in Vitis, be aware, this is the last version that will have it. I'll have to dig into that a little bit more. I'm not sure. They must be coming out with something different. I feel like as soon as I learn one version, one way of doing things, it all changes. Alas is life, though. Anyway, so I got instantly highlighted. So what did I do here? Oh yeah, it looks like the PetaLinux installer is already done. Still installing. I think I'll open another tab. So while that's installing, let me change directories back to my home here. So while that's installed, like while the actual installer is running, we'll skip ahead and do a little bit. There's a little bit more environment prep for the PetaLinux tools specifically. In the ability to create an embedded Linux image for one of your FPGAs, one of the boot options is to create a Linux image that boots from a TFTP server. So in order to do that, the PetaLinux tools needs its own FTP server on your host environment to facilitate that. So before we actually run the installer, let's create that little TFTP server it needs. Even if you don't plan to make an embedded Linux image that boots from TFTP, you still have to create it here just so the actual installer will complete successfully. at least from my experience. So I think, or do I want to stop the network service in the middle of this installation? That may not be smart. Well, we can create the directory for it, at least in the rules. Ooh. When am I gonna learn that that's not the right way to do things? Stop using, there we go. So we're gonna create the rules for our TFTP server first. And I'll have these. I've already got it. This is not changed at all in several versions. So as far as like what the protocol is, what port you put it on. So we'll save that and close it. And then we need to make our directory in our root for the TFTP server. Give it the appropriate permissions. And give it the right ownership. And then for it to fully take effect, you want to start your stop your network service and restart it. Something tells me, even though I did the single file download and this shouldn't be using my network connection, sometimes the AMD tools are a little bit sneaky about still using my internet connection. So I think I'm going to hold off on that and we'll let this installation complete. This shouldn't take too super long, especially since this is a fresh environment. I don't really have anything else running. So I can in the meantime add my user to the dial-out group for using external USB devices. That's a tricky one. I tend to always forget on fresh Ubuntu installations. Well, I think we've done as much as we can do in parallel. While I'm waiting for this to install, instead of just sitting here, I figured I'd go ahead and talk about my FPGA selection that's beginner-friendly / desktop-friendly. And what I mean by desktop-friendly is typically the purpose of an FPGA development board, especially from a company that also sells FPGAs chips, so like AMD development boards. You'll notice a lot of them, they're very, very big and very expensive, and that's because the purpose of that type of development board is to have every single type of possible peripheral that the FPGA chip can support available on that board, because the idea is as a professional or a company, you're evaluating if that's the right FPGA chip, you're evaluating what peripherals you might need, and typically whatever design you create on that dev board, you then have narrowed down what peripherals you need and you go lay out your own custom board for your company's directive or project or whatever. So because those boards are quite big, there's some that are bigger than my laptop here. They also need a big external power supply, so like a big brick that's fairly large. And that's what I would consider not beginner friendly and not desktop friendly. So I gathered a few of my beginner / desktop friendly versions. And these are also, I picked these all based upon the criteria of one, they don't always need an external power supply so that they can be powered by the connection to your host development computer, as well as be programmed via that USB connection from your host computer. A lot of the bigger development boards do also need the separate AMD, not Xilinx, AMD programmer. So I chose these because they meet that criteria. They can be powered off the computer USB port. They can be programmed over the USB port, computer's USB port, and they're smaller. So they're friendly for not consuming up a lot of desk real estate. These are also pretty much the lowest end of the price spectrum for AMD specific FPGA development boards. So I think this one is one of the cheapest. This is from Trends Electronic, the TE0726, or aka the Zinkberry, because it has the same form factor as a Raspberry Pi. It just replaces the Pi microcontroller with a Zynq 7000. That's another commonality. For AMD FPGA specifically, there are two main categories, two main categories that I'm focusing on here. There's the 7 series, that's more of the cost optimized versions, and then the performance optimized versions with the UltraScale and UltraScale Plus parts. I will say these are all 7 series development boards, because that's what makes them more affordable. And then as well as you're not really going to find an UltraScale development board that doesn't also need an external power supply, just because the UltraScale chips need more power because they are more optimized for higher performance than the 7 series chips. So these are all Zynq 7000 chips, but there's also Artix, Kintex, Spartan. This guy is, oops, that's my hard drive. I want to say he's about 100, this is 134. Then I have the Arty Z7 from Digilent here. I crinkle a bunch of plastic. My cat's 100% about to come running thinking I just opened a treat bag. So this is the Arty Z7. This also comes in 2 different versions. There's the Arty A7 and the Arty S7. What that stands for, the Arty A7 has, instead of the Zynq 7000, it has the Artix 7000, and then the Arty S7 has the Spartan chip on it. The Spartan chip is the cheapest in the 7 series chips. So this version of the Arty is somewhere around 200. Let me look here. I have it pulled up just for that. So this is 250, and the Spartan version of the Arty is 120. Digilent does also offer academic pricing. I think it's 25% off. Don't quote me, you'll have to double check on the website. But they have a special form you can fill out using your student email address, so you can get a discount on these. And I also have the Zybo Z7. This is another Zynq 7000 chip. These, as you can see, it's the same FPGA chip, but we're just kind of changing out which peripherals we want here. So this has more PMODs on it, because this has both HDMI, TX, and RX, so does this one. But yeah, that's the other thing when you're picking out a development board. Think about what peripherals you want, how you're connecting. I really like the Arty Z7 and the Zinkberry because they have, the Zinkberry has the 40-pin Raspberry Pi GPIO with the same pinout as the Raspberry Pi, so like the grounds are in the same place, your power's in this, like 5 and 3.3 volt power's in the same place. So I was actually able to create firmware images for this using my Raspberry Pi hats. And then the other one I have here is the pink Z1. And I'm not handling these well for ESD. They'll survive, hopefully. So this is the pink Z1. This is a fun one. There's a lot of Python Jupyter notebooks for this. That needs a whole other video on itself for tutorials, but this is another good beginner one, has its own kind of like community to it. And you'll probably also notice that these do have separate DC barrel jacks. Depending on your design, how intensive it is, particularly if you're running a full Linux image on it from an image you created using PetaLinux, you will need to consume a little bit more power than your USB port can provide, because a typical USB port on a computer, it's 5 volts, and the 2 different standards I know off the top of my head are either 500 milliamps or 900 milliamps. Sometimes the kernels are not always programmed for that 900 milliamps, so it will kind of top out at that 500 milliamps. I have gotten full embedded Linux images to run solely off the USB port for the RDZ7, but they're pretty bare bones, they don't do a lot. Certainly if you want to do anything with video processing like HDMI, you would need to go ahead and switch to having that external power supply as well. But special use cases, for the most part, you can do most of everything you need with these boards solely powering off your USB port from your computer. So I think that covered everything I wanted there. I'm also curious if you have some other AMD development boards that fit these criteria that I have not heard of yet. I would love to hear of them. So anyway, let's see, it looks like we still have 40% left on our installer here. So let's go ahead and let that finish running. So now that the installation is completed, first thing to do is, I had mentioned that there is an installation script built within the actual installation paths or installation directory of Vitis and Vivado itself that you can run to make sure you got all of your package dependencies before you launch any of the tools specifically. So let's run that real quick, especially since I deviated a little bit away from my tried and true script there and had some problems. But this should clean everything up for me if I did make a mistake. So we are going to change directories into that. So I have it saved here. Should know better than to hit, not Command C, it's Control C. Anyway, so it's both in the Vivado 24.2/scripts. It's in Vivado and Vitis in the scripts folder. It's the same script, it doesn't matter where you run it from. And then it's just, the script itself is titled just install libs.sh. You do need to run that with super user privileges. So let's see if I missed anything here. Not so far. Maybe I did miss something? I feel like I see some new things. The thing that kind of sucks is like I have tried to go look for this script in the installer folder here, trying to like run it ahead of time, and it's not here. It doesn't become available until after you actually install or run the installer, which I find interesting. So did it not actually? It says 0 upgraded, 0 newly installed, 153. Let's scroll up here. Or did it have? For more information, oh, it's got a log script. Let's go look at that. So it is tools. So it should be in Vitis, yeah, that's where I ran the script from. Scripts. Installation libs. Here's my Did I just want to see if I missed anything here. Looks like I did miss something. Well, okay. Looks like I missed this libnss3. I'll have to do a keyword search. So this is interesting. I don't remember ever having to have that package before. I'll go check my previous scripts, but looks like there are some new things for 24.2 specifically. I'll do a keyword search through this log a little bit later and update my written version of this so it's a lot more clean. But kind of wanted to show you that process so you know, you can kind of learn from it yourself as you go on, because I'm sure anybody that's used the AMD FPGA tools previously has probably had to switch back and forth between versions, install several different versions, so the more you know. Okay, so now that we have all of our package dependencies good and ready to go, we do need to install the cable drivers for the actual programming of our FPGAs. So let's change directories into that. So that is actually in the cable drivers, and then the script is just called install_drivers. I will put these locations in the written version of this tutorial. So looks like all the drivers, so we've got our Digilent, Xilinx, FTDI, regular Xilinx, all that installed successfully. I did forget to mention before running that, make sure you don't have any programming cables plugged into your computer before you run that, because it does mess with the actual installation. I think it'll actually stop and tell you you've got something plugged in if it detects anything. Okay, so now that we have checked our package dependencies, installed what we messed up, installed our cable drivers, I'm gonna change directories back to my home. Oh, forgot to, helps if you put a space in there. So let's source the tools to our environment and actually try to launch this. So let's try to launch Vivado, just settings. So our settings script, and then Vivado, let's just see if it launches. Moment of truth. Graphics want to scare me there. All right, so it looks like we're good there. And then let's do the same. I think this is redundant. I think you only have to source the Vivado I think the settings, the environment script in the Vivado directory and then the Vitis directory are the same, I think, but actually let's just test that, because it would be source tools Xilinx Vitis 24.2, which I know if you source the Vitis toolset you can also launch Vivado, but let's just try to launch Vitis. I think it's all the same environment script regardless of where you source it from in that directory, and it looks like that's the case. Okay, so let's make sure this launches. I will say sometimes the new Vitis, the graphics with the accelerated graphics seem to have given me a little bit of problem in the past, but it looks like we're good here. So awesome, we are good with Vitis and Vivado, so let's go install PetaLinux now. I think let's start with a new tab here. And I will say the only thing is PetaLinux doesn't make the installation directory for you like Vitis and Vivado does. So just for organizational purposes, you'll notice that within the Xilinx installation directory, it creates a separate directory for each individual tool. So just so I can keep everything organized myself, I do like to make another folder in here called PetaLinux. And I'll do a specific, like underneath this, there's a specific version, so if you have multiple versions installed, there's just one tools/Xilinx/PetaLinux, and then all the different versions will be here. I follow the same thing with PetaLinux here. Again, that's not a requirement, that's just what you can install PetaLinux pretty much anywhere as long as it doesn't mess with the functionality of Linux underneath, aka don't install it in the device folder. But just for organization, because I like to be organized. I already messed up my password because I'm talking. There we go. Okay, so we've got our new installation directory here. Then we need to give it the correct permissions, which for PetaLinux is going to be 755 instead of the full 777. That is explicitly mentioned in the user guide installation process. And then we're going to come and let's see, we need to, oh, before we get to the installer, let's change ownership of the installation directory, get that correct for my current user. And then we're going to change directories into the downloads folder where my installer is, and I need to make the installer executable, or no, give the installer the 777 permission that's already executable. Oh, I already changed directories into there, that's why good job. What did I mess up? Oh, because I didn't fill in. There we go. And now we are ready to run the installer. Where? There we go. Didn't know where my cursor was. Okay. Maybe. Yeah, PetaLinux. Okay, well, there we go. So we'll run the installer and then actually specify our installation directory, which was the tools directory, or the PetaLinux and the Xilinx tools directory we just created in the specific version. Command not found. Is it not? Maybe I do still need to make it executable? Why are we mad? Let's try that again. Does it need? Well, I never said I was a Linux expert. Said the opposite earlier, but. So, this will probably give us the same warning that since we're a minor version off. Yep, there we go. There is, at this point, there is no way to get rid of that fully unless you hard code the version checker in the script to look past that. Like I said, I've never had an issue with it, so we'll press, we have to agree to the license from the command window, so we'll do enter, and then Q to exit, yes to accept, Q to exit, to accept, and there we go. I think it's kind of interesting, even though I've done this installation process 100 times, I managed to hit hiccups in this, which hopefully that's kind of helpful to watch, or you can just laugh that my brain cell has left its orbit again. It's up to you. This is why typically, I do an installation tutorial for every version. Typically it's just in written form, because I do kind of feel like most of the time it's easier just to copy and paste a lot of these commands and run through it. Also, when you're installing and waiting for things to install, at least I default to the written ones, but hopefully you just like my commentary at this point, / troubleshooting skills. We have successfully been set up and is ready to use. So let's test that out. And change directories back to my home. So we'll source the PetaLinux tools to our environment. So PetaLinux, there is no GUI for it. It's just a command line tool. So let's source. So at least sourcing the tools to the environment didn't crash and burn. And again, since we're a minor version ahead, I get the warning this is not a support OS. Don't worry about that. Like I said, it'll be there every time. So, I forgot what else here. Is there anything we can do? Well, it looks like let's config. Oops. So it looks like everything's been sourced to the environment correctly. we're good to go. So it looks like we have our successful installation. So now that we have our successful installation, I'll go ahead and close off some of these, and we can get into creating a basic project for one of these FPGA boards that I mentioned. So I'll save this for later. I already have, let's relaunch Vivado here, since I've already got the tools sourced in this window. And it is worth mentioning, if you're not super familiar with Linux, the tools are sourced in the environment for that particular window. So if you open up like a new command window, you'll have to resource the tools to that environment. You can, if you use the Xilinx tool, or AMD tools, still getting used to that transition. If you use the AMD FPGA tools enough, you can add to your path at startup for Ubuntu to where it just automatically sources that tool script to your environment constantly and in every window you open. I just source it every time I need it. So when you launch into Vivado, the first thing you're going to do is obviously create a new project. So, and by default it wants to put it on Ubuntu, or Linux, it wants to put in your home users directory. So which one do I want to do? Let's do the RDZ7. So let's do RD, I'm just going to give it a random name here. Let's do Project 0. Next. I don't want to specify sources at this time because I don't have any pre-made HDL source files to add to the project at this time, so I'm going to go ahead and check this box so it doesn't try to prompt me for it right now. The second option for Vitis is an extensible platform. That is for the accelerated project, so if you're going to create, that assumes you're going to create an embedded Linux image, and then you're also going to have an accelerated kernel built in to where you're like, your application space running in Linux basically has hooks straight into the programmable logic of the FPGA. That's a different time and place and not a beginner topic, so we're just going to make a regular old FPGA project at this point. And then this next screen is selecting your target FPGA part or FPGA board. If you're starting with a custom board, you'll just choose your direct part. That means you're not going to have any like presets or anything for any development board. You'll have to configure all of the settings, like your boot mode, all of that, peripherals by hand. Since we have a development board, we're going to switch from the parts tab to the boards tab. And since this is the first time I've run Vivado, all that'll be in here are the AMD boards specifically. So let's refresh this, because there is a Git repository on the back end that Vivado talks to on in AMD's GitHub repo for all their board parts. You can make a local repo for your own board parts and add that to Vivado's repo path. Again, that'll be a separate tutorial. So this usually doesn't take that long. It's just taking longer since it's the first time. Let's run. So, then by vendor, Digital is a default vendor in here. So we do have, let's see, RD Z7. There's a couple versions. I have the larger part, which is the Z7-20. Next, and finish. Okay, I had to take a little break there, and now I have my typical lab helper, but now that we have our project, our newly created project here, there's a couple avenues you can go when designing a firmware, or when making a firmware design in Vivado. You can go the traditional all HDL hand-coded route, or there is a graphical GUI type interface for instantiating IPs or intellectual property blocks, or your own HDL code as well. I highly recommend this for development boards in particular, because that's where you get to take advantage of the board preset files. So the board preset file is what we selected when we specified that we were using the RDZ7 board. And I think it's the better route for people that are newer to Vivado or FPGA development in general. So the first thing we're going to do is create a block design. So we'll just call this RDZ7. It'll append .vd as the file type. Click OK. And then this opens up our programming, our empty window here. Now typically the first IP you want to add is your core processing system, whether that's a soft processor if you're using an FPGA with no actual physical processor built into it. So like the RTX, you can use the microblaze, or if you want to pull in your own RISC-V. With the Zinc 7000 chips like the RDZ7 has, there is a built-in dual ARM core processor in the actual fabric of the programmable logic of the FPGA. Kind of a mouthful. But there is an IP in the catalog that you instantiate in your HDL design, whether that's here in the GUI or in your actual logic code. You do need to instantiate that to be able to configure the ARM core as you like. Even if you're not using it, you do still need to instantiate the Zinc core to start up the clocking structure, because the actual main clocking structure for the programmable logic is fed through the ARM core of the Zinc chip, so you won't get, your clock won't make it to your programmable logic if you don't at least start up that Zinc chip or the Zinc ARM core. So that's what we're going to do first. We'll search the IP catalog for Zinc. Did I choose the wrong? Hold on, did I make another mistake here? Define project manager. That's not a Zinc part number. What happened? Did I choose the wrong? That is RDZ7. Oh, that's odd. Did I accidentally click? Okay. Well, this is just a video of mess ups you get to watch. So let me, hold on. So say you find yourself in a situation like me here, where you somehow accidentally chose the wrong part. If you ever need to switch parts or dev boards in a project, we'll just come back to settings here, and under general project device, I swore I chose, that's a weird, I don't know. I can't tell if that was a me mistake or a Vivado mistake. But let's search for the RDZ720. There, see that part number? So XC7 is any of the 7 series parts, and then the Z after the 7 stands for Zinc. So that's how I could tell, like, this other part number here is obviously not a Zinc part number, which is why the Zinc IP wouldn't show up in my catalog. So let's click OK. And oh yeah, I think I want my default. Let's do VHDL, and I want my default library to be work. So let's click apply. That didn't. Well, why did that not say listen? This is what happens when you work too late, apparently. I guess the FPGA powers that be are just not happy with me. You guys saw that. Okay, so part number, cool. Okay, we have the right part number now. Sorry for the little detour. So we'll come back, we'll open our block design here. And search for, so now we have the Zinc Z7 IP here. Oh yeah, let me put, where, forgot I need to be focus, do not disturb. So when you first add either the microblaze soft processor or the Zinc soft processor, you'll get this run block automation. So that'll apply some general presets that are necessary for any processor, but also when you have a specific dev board chosen with its board preset files, you'll see this option of apply board preset. It will configure the ARM core, the Zinc, for your target dev board. So there are dedicated what's called MIO ports on the Zinc processing FPGA chips, well, system on chip, or SoCs, where things like SPI interfaces, I2C, UART, etc. can go straight to the ARM core without being routed through the programmable logic and you needing to instantiate or write that physical layer interface for the respective SPI, I2C, UART. So depending on which one of those are physically connected and routed on the PCB, that's what the board presets will configure. So we'll click OK, essentially configuring the Zinc IP for the RDZ7. And then you've got this, when you have a board selected as your project target, you'll have this board tab here in the block design. This will not be present if you just choose a straight FPGA part, since it doesn't know what your board looks like. So like I said, the system clock is actually routed straight to the Zinc, so I don't need to connect that here. But as you can see on the RDZ7, we've got things like our 4 push buttons. We've got, where are the LEDs? There's some RGB LEDs. I'm just blind right now and don't see where they are on the board. Why am I blind? Oh, they're right above the push buttons. See, Moxie, this is what you're supposed to be helping with. So yeah, we've got LEDs. There's a couple RGBs as well. You'll see that listed here in the board presets of what available pins there are, as well as the shield pins 0 through 13. That's the Arduino shield there. So just for fun, we're gonna add, well, this will be a fairly simple design. You could add all of this. I'm just gonna do a couple since this is just demo purposes. Let's start, we've got 4 LEDs, so 4 outputs. So you can right click on a peripheral and then you can see what the properties are, or connect board component or auto connect. I recommend doing the connect board component, and what it will do is give you a filtered view of the IP catalog for the specific IPs that are compatible with that peripheral. So because LEDs, it's a general GPIO, at the top of the list you have AXI GPIO IP and which channel, like the channel 1 or channel 2 of the AXI GPIO IP to connect it to. If I had chosen the auto connect option, what it'll do is it'll just default to whatever's at the top of this list. I'll go ahead and choose that anyway. So you'll see I've got AXI GPIO, it connects it, takes care of the naming, and then we have this option up here called Run Connection Automation that now appears. So if you run connection automation, what this will do, it will take care of connecting up the AXI interfaces between your processing core and any of your peripheral IPs. Pretty much all of Xilinx's, pretty much all of AMD's IP catalog communicate with each other via an AXI AXI bus. There's plenty of translation IPs that they have in their catalog. It's also a fairly straightforward protocol that you can write your own. It's just a handshaking type protocol. I've written simple state machines myself to interface with both AMD's IPs, create my own custom IPs, that type of thing. The big thing on that is making sure you have the clocking structure and the resets distributed to everything right, that the endpoint logic, you have your clocks all synchronous as they need to be, and it's on the right reset network, all of that. What's great about Run Connection Automation is it will take care of all of that for you, connecting with the right clock domain, resets, all of that, which is another reason I think the block design, the graphical method, is ideal for beginners, as well as already defined dev boards. So we'll let that run, and you have this option for this little circle arrow icon that regenerates the layout, so kind of helps it not look like spaghetti for you. But you'll see it added your processing system reset to give you a synchronous reset here. which is also driven, you've got coming out of the actual Zinc ARM core itself, CPU, and then our AXI interconnect, which allows us to, so let's see, let's do an input here. So if we have another peripheral IP, you'll notice, so we could add this as the second channel of the GPIO, or we can instantiate a new GPIO IP. So let's do that just because I want to show what it looks like to have multiple IPs connected here. So we've got our run connection automation, and we'll let it handle. So as you can see, this interconnect is what handles, you can have multiple input devices driving multiple output devices, and what it does is it assigns each peripheral on the bus its own AXI IP address, which then you can which in your software you can then write to, from the Zinc side, you're like, I want to write to AXI address, what is this, 4120 for my GPIO 0, which is my LEDs, or write to address 4121 for to read from my buttons. So you can go through, kind of repeat that process for whatever IPs you want to add. If you want to add custom, you can. That's where, if you come into add sources, add or create design sources. So I can either, with add files, that'll let me go through and search my computer for existing HDL files, or if I want to create something. So simple state machine. And then if I click finish, it'll have me give my architecture name, have a clock input. If I want to do a active low reset, let's say I have some sort of signal out. Oh. Signal output, it's just my random signal name. If I come back to sources, you'll see as my hierarchy is updating, I've added let's create a blank HDL file with my architecture and entity already declared here, and I can continue to add my own, say I've added my own custom HDL with my actual state machine in here. I can then come back into my block diagram, and if I right click anywhere in space and use this add module feature, you'll see now I have my simple state machine, and it has all of, oh, I forgot to make it looks like it's still technically an input. So if I want to change that, actually, if I want to change that, it's fairly, change an output, control save, I'll get this show IP status. It will need to upgrade the IP, and what that will do, I know, I'll generate sources here in a minute. All sorts, but you see now it changed to my actual output. And then of course connection automation, because it detects an unconnected clock and reset, so it wants to connect that to the existing clock structure. So by default it wants to put it to the main clock source for the entire design, which is the output clock from the Zinc processing system itself, which since that's what everything else is on, we'll do that. Regenerate, and rerun. My IP status is up to date, so let me rerun that. And so say, and then just as a quick thing, we can do signal output. If you right click on this, you can say make external or use Control T. And then I've got my little output port to bring the signal external to the block design. Otherwise the signal's fully contained in, like, this block design gets translated into HDL itself and synthesized into the design. Obviously all of these IPs that you see graphical representations of here, they're the same as my little simple state machine. There is underlying HDL. So let's say I've completed my design here. Now if I want to validate, check for errors here. Either what's not connected. Oh, I forgot to connect my reset. So since my clock source is the actual F clock out, I want to connect to this reset, which is the reset that clock is associated with. Anyway, so I've got my reset connected. Let me validate my design again here. And validate there's no errors or critical warnings into the design. So we'll say I have my logic design done here. I'm going to save my block design. Now I do need to instantiate the block design in the overall project, and I need to bring these signals up to the top layer and have a top level wrapper such that I can connect my signal outputs, my actual signal package pins, so that I can connect my actual signals to specific package pins on the FPGA. So now that it's saved, I'm going to come to the block design here in the sources hierarchy window, right click and create an HDL wrapper. And then if I open this file, you'll see, so I've got all of my signals, all of the signals that need to be external pulled up to the top entity with ports here. It's got my block design instantiated, so you see I've got my VHDL component and then actual instantiation here. And let's say, so if I didn't want my signal output to actually be routed to a specific FPGA package pin, say I wanted to add some custom logic here in my top level wrapper to do something with that signal, I could. So I can just delete that because I don't actually want that to go to an actual output pin. Or I take that back because I think I want to need to show you custom constraints. So now that I have my top level wrapper, because I am using a dev board with dev board presets, for all of these predefined signals, I don't have to manually create a constraints file. A constraints file in Vivado is what actually maps your signal names in your design to specific package pins of the FPGA. So at this point, I could just go ahead and run synthesis, implementation, generate a bitstream. But since I've got my custom signal output here, I'll leave that be so we can go through actually creating a custom constraints file. So I could go ahead and go through add sources, add or create constraints, pull up the data sheet for this particular part and choose a pin that way. That's a very valid way, but I found something a little bit more, especially if I have a design with a bunch of custom pins that I need to route, something a little bit simpler for my preference. So if I go ahead and run synthesis, and this should synthesize fairly quick, it's a pretty small design. You can kind of come to this design run and see the status, because what it'll actually do is it'll go through and in a block design, it'll go through and synthesize each individual block in the design and then run the overall synthesis for the project. So I'm just going to close this window since for the IP status. Why are you saying this file's been changed? Or just, okay. I'll let that run for a minute. Since I left this as a blank, I might have to actually throw some logic in here because it might be kind of mad at me that there's nothing in there. Might have to just throw like a flip-flop or something in there, or a register. Yeah, so each of those, total time for the block design was 2 minutes to synthesize. Now that our design has synthesized successfully, what we're going to do is open up the synthesized design. And at this point, we've just taken the actual HDL itself and translated it into machine code to go onto the FPGA. We've not actually run implementation or place and route, so we haven't done timing or anything like that on this design. Oh yeah, so I have a critical warning, could not resolve non-permanent black box cell, because there's nothing in there. Normally you would not want to ignore things like that, but I might have to go throw something in there. So On a new design like this, when I haven't created any constraints, nothing like that, what I'm going to come into is I want to go to I/O planning, and you get this nice, pretty view of the ball grid array of the FPGA itself and which specific pins are still available and which pins actually have things already on them. So because this is a dev board with board preset files, you'll see that the constraints file from the underlying board presets are already here. So like all of these package pins are where the DDR are already routed to. Let's see, we've got our buttons here. So it is worth noting on the dev boards that things like the LEDs and buttons are routed to those specific package pins. So those I can't necessarily repurpose. The true repurposed I/O on dev boards like this are stuff that are going to like the Arduino header, the PMOD, that kind of thing. So I've got my custom signal. I can put it pretty much anywhere. So let's choose, we're gonna come down to, you'll see you've got this little, in I/O ports, you've got this nice little thing that will show you. I'll just maximize this here and expand everything. So everything that has a package pin and I/O voltage already assigned to it will have this little yellow check mark to it. And then anything that's still not assigned typically kind of shuffles down to the bottom. So this is where I can choose my package pin. So let's do J16. I'll come down here, J16. And so that's in bank 35. You do have to, all the IOs that are grouped in a certain bank, that bank is fed by the same voltage supply rail. And while those different supply rails, you can set them to different values, you can't have different voltage settings in the same bank at the same time. So like if I set the supply voltage rail for, what bank is this? Bank 35, if I set that to 3.3 volts, all of the pins that I assign in that bank have to operate at 3.3 volts. So it looks like the buttons are already at, I think they're at 3.3. Let's double check here. That would be, yeah, so my buttons are all LVCMOS 33, so that's what my signal also needs to be. And now that that's assigned, I can come up here and if I save, this save button is now for the synthesized design. If I click save, yes, I know it's out of date, but more importantly, it will come up and ask me if I want to go ahead and create a new constraints file, or if I had already created one using the add sources option, I could just add these to that existing one. Like I said, when I'm creating a new project like this is how I like to create my constraints file. So I'll just name this RD IO. Click OK. And then it's up to you whether you want to do it here in the synthesized design or if you want to wait until the implemented design. But you do have a timing constraints wizard. Oh, I actually need to, this is a new this is a new layout. I still think, let's go ahead. So for timing constraints where you're setting like your actual input delay and output delay for all of your signals for your setup and hold times, that you can do in this wizard as well. Constraints wizard, that's what I wanted. So I have my existing primary clock, which is already the source clock for the RD. You'll notice it's locked because it's part of the board presets. So I don't need to add any more primary clocks. If you were doing a custom design, you would need to. Again, I'm using the primary clock for everything, so I don't need to add any generated clocks. I don't have any forwarded clocks. No feedback delay. Now we've got past all the clocks, and now we're to our input delays. So we can add things like our trace delay, min and max. This isn't going to be very much on this board, especially for this. So we've got a 10-second clock period. I'm just gonna say my minimum delay is 1 nanosecond, maximum is 2. Typically, if you were doing a custom board, you'd actually measure the length of the trace from your peripheral to the FPGA package pin. I mean, on something like a button, that's not gonna make a big difference, but once you start getting into like higher speed peripherals, this can have a pretty big impact. So we'll go ahead next. And then with our setup and hold time, I'm gonna say, probably do 2-second setup. Probably only need like, scene trace delay max, there's 2, min 1. So these are same for our LEDs. Don't really have any combinational delays for this. It's a pretty simple design. Don't have any physically exclusive clock groups. Don't have any of these. If you have any asynchronous clock crossing domains, you can add here. Of course, you could add all these constraints by hand. I think it's just kind of helpful to have the GUI here. So we'll go ahead. Oh no. Let's see. We'll open our constraints. Come on. Did that save none of my constraints? What happened? Well, I'm just having all sorts of technical difficulty here. Let's go back and read that message. So as a general rule of thumb with Vivado, it gives you lots of info, lots of warnings. I typically don't get into the warnings unless I'm really stumped on something. Critical warnings and errors are the two things you don't want to ignore. So you can see we've got, it created our actual clocking constraint, or timing constraints here. I don't know why it was mad the first time. This is a night of weird quirks. So now that I've got all my timing constraints there, go ahead and close the synthesized design because I do need to rerun it now that it's out of date. Rerun it with our new constraints. And since we just changed I/O routing, this should take even less time because it should use the cached results from the last run. That is something you can disable here in settings under synthesis. So you can do incremental synthesis. If you disable incremental synthesis, that will just it'll just rerun it every time instead of using cached results, which sometimes it's helpful, other times you want to have your design checkpoints so it can give you shorter synthesis runs, especially in your larger designs. So now that we've completed synthesis, let's go ahead and run the place and route. We'll see if our timing constraints work when we actually, so place and route is where you take your design, it's been synthesized for FPGA land, and you actually route it on your specific target chip. So it'll actually put it through, go through all your different logic gates. So it'll actually go through and whatever your logic design is, implement that on the actual logic gates or combinational logic blocks that are within your target FPGA. It already failed, oh no. Let's see. Oh, yep, and it's not gonna let me get away with the black box of nothing in my simple state machine. So let's go ahead and fix that real quick. So we'll just do something like, we'll just map signal output. Let's just map that to ground. Something super simple. We'll save that. Let that update. So it's interesting. Some versions of Vivado will say, oh, let's update a block in your block design. This one wants to go through and upgrade IPs every time. Great, completed. So generate block design, that's just wanting to rerun synthesis for the one, my simple state machine, since that was the one thing that I changed. Yeah, it didn't know how to map nothing into actual logic blocks on the FPGA. I should have known that that wouldn't let me get away with that. So, see, let it rerun synthesis for this one block in my block design. So now that that's run, let's go ahead and we can, so even though the synthesis is out of date, if you click run implementation, it's just kind of a shortcut. It'll go ahead and relaunch, start at synthesis for you and relaunch, and then just go straight into implementation for you. So, oh, looks like I failed timing, so let's open up our implemented design and see. If I come to the negative slack, oh man, let's look at we can filter for our failing endpoints. So it looks like our arrival time is actually 8.9 nanoseconds and the required time needs to be 5.8. So we need to go back and edit our timing constraints. So like I said, when you use board preset files, there's already all of the constraints, like the pinout, timing, all of that, since that can't change. Those are already defined. There's XDC files underneath the hood here you can't see. I think, so let's do this. I'm gonna close my implemented design. Typically you would look at your setup and hold time, and depending on how bad you're violating, you know how often or how much you would need to change your setup versus your hold time. So it looks like for this, I would technically need longer setup time. What I think I'm doing is, by me setting it here, I'm probably conflicting with what's already in the constraints in the board preset files. So if these were custom things, I would extend my setup time and my hold time here until I met this. But in this case, I think I'm just gonna go ahead and comment them out because I think I'm conflicting with what's going on underneath the hood. I'll comment out save, you'll see that throws the design out of date, so I'll come back and rerun implementation. We're already into initializing the design. Let's see that. Yeah, because that synthesis run took 50 seconds. So, especially since we didn't really change the design at all, we were just changing constraints. All right, implementation complete. Let's just go ahead and open up the implemented design, make sure we don't have any critical like timing warnings or methodology warnings. Because like I said, regular level warnings and infos you can pretty safely ignore. We just want to make sure we don't have anything critical. So yeah, now our setup and hold times are good. No critical warnings in my design methodology. So let's go ahead and we'll close the implement design, and the final step is to generate a bitstream. So this will actually compress your place and routed design into the final format, a bitstream that you can then program onto the FPGA. It tells it how to configure all of the logic gates within. Your bitstream is ultimately what you'll store in like your non-volatile flash on your target board, whether that's in the QPSI flash memory. If you want to play with the bootloader, you can store it on an SD card, that type of stuff. Controlling that, we'll get into the software element of it. Assuming that this bitstream generates okay, looks like it did. We'll go ahead and open the implemented design again, just double check there's no glaringly wrong things. Doesn't look like it. So we have no critical warnings. So at this point in the design, the quote-unquote hardware aspect of it is complete. We have the interface to the actual ARM core instantiated. We have our customs design for our programmable logic. So the next step after this would be to take your design and we're going to export it. So we're going to export the hardware, and we do want to include the Bitstream within it. I just let it name it as wrapper. I like to, any hardware designs, I like to export them into the top level of the corresponding Vivado project, just so I can keep track of it and I know which hardware goes with which Vivado project. So once you do that, this exports into the .xsa format. It's AMD's proprietary compressed format. I think this video is already long enough as it is, but so this XSA file is what you'll take and you'll import it into either Vitis, which is the software development IDE for actually developing the application that will run on the ARM core and configuring like the bootloader part and all of the software elements of it. If I were going to create an embedded Linux image to run on the ARM core and interact with this design, I would pull it into PetaLinux. Those tutorials, I definitely have lots of past tutorials on those. If you want an updated 24.2 tutorial, let me know. I think I've been rambling on long enough in this particular video, so I'm sure you have plenty of feedback for me, so let me hear it in the comments, and I'll catch you in the next video. Bye.